This is View Calculus class. We're doing topic 7, which is the equations of tangent and normal lines. So let's start with a quick crash course in some algebra / pre-calc. When you're asked to write the equation of a line forever and always, till eternity, you need to do 3 basic things. Find a point, find a slope, write your answer in point slope, right? So you find a point, x1, comma y1, you find some slope that we're going to call m, and then you write your answer as y minus y1 equals m times the quantity x minus x1. If you're asked to solve for y, you can actually just make it y equals m times this x minus x1, and then add the y1 on the other side on the outside, right? So you should not do y equals mx plus b unless asked. So the reason I say that is that invariably when people do that, they end up multiplying or adding wrong and taking a right answer and turning it into a wrong answer because they distributed something wrong or added wrong or whatever. And it's the worst. There's nothing more frustrating as a math teacher than seeing your student take a right answer and then just accidentally have like a brain fart moment and do something silly and get a wrong answer. It's really, really frustrating. So, and it's frustrating for the students too, because that's not what you want, is like, oh, hey, it was a right answer and then I did something silly. So again, answer in point slope, right? This is the best possible answer. Y minus the y value equals m, x minus the x value. The only reason to change something to slope-intercept form is if you are expressly asked to do so. Otherwise, it's just not worth it. All right, so let's get back to the calc. So if I want to find the slope of a tangent line, remember that all of this stuff we started back in topic 3 when we did the limit definition of a derivative was to find the tangent slope. So the tangent slope at any x value is f prime of x, okay? So if f of x is your function, the tangent slope at some arbitrary x value is f prime of x. But if you want to find the numerical value at a specific x, you have to plug in that x value, meaning if you want the tangent slope at x equals a, you have to do f prime of a. Once you know that, if you already have your point, that's it. You can use point and slope, boom, answer in point slope. So we're going to go ahead and walk through example 1. So example 1, our function is going to be f of x equals x squared plus 3x, and we're going to find the tangent slope at x equals 5. Okay, so we need 2 things, right? Per the instructions, point, slope, right answer in point slope. Okay, cool. So the first thing I need is a point. Well, I know half the point. It's 5 comma blank, right? The way we find the y value is plugging in f of 5, which is going to be 25 plus 15, so I get 40, right? I also need a slope. Well, the slope, based on this thing I wrote up here, is going to be the derivative of this function evaluated at 5. So I have to find f prime of x first. F prime of x is going to be 2x plus 3, right? So f prime of 5 is going to be a 10 plus 3, which is a 13. Okay, so I now have my point. I have my slope that I called mt. You don't have to, but I called it m sub t for tangent line. And then all I have to do is write my answer in point slope. Y minus the y value, so y minus 40 equals my m, 13, x minus the x value, which would be the 5. If you want to add the 40 to the other side on the outside of the parentheses, you can, but that's a perfectly acceptable, totally great answer, and you should just leave it as y minus 40 equals 13 times the quantity x minus 5. There's no incentive to clean that up at all, okay? All right, so let's talk about what normal slope is. So the tangent line, right? So if we were to look at a visual of what a tangent line is, right? A tangent line looks like this. Like if you were on a roller coaster and the roller coaster broke and you actually like accidentally flew off the roller coaster, ignoring gravity, you would fly out tangentially. So if your little light cart, like let's say you're like Indiana Jones in that cart in the mine, whee, okay, and your cart falls off the track and flies, it would fly tangential to the curve, right? And the only reason it would actually bend is because of gravity, but let's pretend you're like, I don't know, in a zero gravity, no gravity, no air resistance, no anything, you would fly off tangentially. That's the tangent line, okay? The normal force on Earth is the thing that pushes you down so that you don't plummet, or the thing that pushes you up so you don't plummet through the ground when you're standing on the Earth. Gravity pushes you down, the normal force pushes you back up. The normal line is perpendicular to the tangent line, okay? It's perpendicular, so this red thing is called the normal line, okay? So what's important here is that the normal line is perpendicular to the tangent, and if you think back to Algebra 2, you learned that perpendicular lines have opposite reciprocal slopes. So the normal line has the opposite reciprocal slope, meaning that essentially, if you know the tangent slope, right, M normal is the opposite reciprocal. So what we mean by opposite reciprocal, if we think like a caveman, so opposite reciprocal just means flip slope, change sign. So for example, if we were to look back at the example we just did, right, the tangent slope was a 13, right? This was my M tangent. So if I wanted the normal line, right, so this was my normal line, or if I wanted my normal line, I would keep everything else the same. So y minus 40, I'd keep the x minus 5 the same. The only difference is my tangent slope is 13, so my normal slope is a negative 1/13 because I flipped the slope and changed the sign. So this would be my normal line, right? All the other work stays the same. The only difference is that you take whatever you got as the tangent slope and you flip slope, change sign. Okay? Cool. So we're going to go ahead and walk through some examples of both tangent and normal lines. We have examples 2, 3, and 4 where we'll both find the tangent and the normal line, and we'll do that in the next video.